Good morning, everybody. We're going to continue now looking at quadratic equations. Last class, we talked about what quadratic equations and quadratic functions were and where we find them. We know the graph of a quadratic function. It's ax squared plus bx plus c. We know the graph is a parabola. All right. Now, when we look at the graph, analyzing this graph, what are the important pieces that we have to know? There are actually four important pieces. What we need to know from the equation to graph it. First thing, we need to know what's called the vertex. The vertex is the highest or lowest point on the curve. If it looks like this, we have the lowest. If it's like this, it's the highest, which we talked about in last chapter. We're talking about local maxima, local minima. Since this is this lowest, this is a minima. But since it's on the bottom of the entire thing, it's the absolute minima or global minima. And this one's the highest, so it's the absolute maximum. It should be maximum because it's singular. Okay, so from there, from this equation, we're going to look at finding those two pieces, or whether it's highest or lowest point, and the location of it. The next thing we have to know is the direction of the graph, because obviously it can either be up or it could be down. And we're going to look at how we just look at the equation and determine which one is going to be true. And if it opens up, then we have a minimum. If it opens down, we have a maximum. Then we have to find something, because as you can see, the quadratic equation, the parabola, is a perfect shape. It's symmetric. When we look at the symmetry of it, if we drew a line down the middle of it to the vertex, when it's equal both sides, we call that symmetry. Now, what we need to find in this equation is called the axis of symmetry. In other words, what is this line that makes it equal on both sides? Because once we find that axis of symmetry, then we could just, once we plot one point, we just copy the points on the other side and we're done with the graph. So direction, we have to find the vertex. And the intercepts. The x-intercepts. Because that's what we do when we're going to solve them. All right. Ooh, look at these. We have Structures of quadratic equations. I'm simply going to write QEs from now on for quadratic equation. We have two types. One is in standard form, and the other is called the vertex form. So the f of x equals this one, and it equals 0. And this one here will do the same thing. But on this side, that's our vertex form. They both have their pluses and minuses. They both have the benefits and detriments. There is no easy way to find the graph, but these make them more simple. Okay, first off, we'll start with the vertex form. From the end of chapter 2, the transformation, quadratic equation looks like this. So let's build this thing. First thing we look at is we have a horizontal shift. So we have and this number added and subtracted to the x. This is the horizontal shift. Then we have the vertical shift, which is outside the function. So far, what we've done, we've taken the origin and moved it to this new place. And then the last part, we have the horizontal shift, we have the vertical shift, and then we have the transformation, the vertical transformation. The A in front does a lot for us. The A tells us the direction of the curve, whether it opens up or down, and it tells us the shape. Is it going to be skinny or is it going to be wide? All that stuff is given by this function here. Now, inside that function, inside the vertex form, if we're given to it this way, we can tell the vertex. The vertex is at the point HK. The same thing we did when we did the center of the circle in chapter 1. It's always the opposite sign inside the parentheses, and it is what it is on the outside. So there's your vertex. The axis of symmetry is the x value of the vertex. Just think about it. Where is the middle of this graph? It crosses on the x value of the vertex. The direction of the parabola, it opens up if A is positive, and it opens down if A is negative. So if it's positive or if it's negative. And then the shape. It's narrow if A is bigger than 1. No, it's narrow if A is between 0 and 1. It's no, it's right the first time. Yeah. If A is greater than 0, greater than 1, what am I doing? It's 3 o'clock over here. If A is greater than 1, then it's narrow. It's wide if A is a fraction. So let's look at an example here. What if I gave you this function? And this function. So for both of these, tell me the vertex, the axis of symmetry, the direction, and the shape. Okay, so the vertex in this first one. Remember, vertex is HK. Here's H, there's K. So it's positive 1/2, negative 2. Remember, it's always opposite what's inside the parenthesis. Outside, it is what it is. The vertex for the second one is negative 1, 5. The axis of symmetry, x equals 1/2. I get 1/2 from. It's positive 2. Positive 2. Negative 2. So the axis of symmetry is the line going through the x value of 2. The axis of symmetry here is the line x equals negative 1. The direction, A equals 3. It's greater than 0, so it opens up. The direction here, A equals negative 2. It's less than 0, so it opens down. It looks like this. And the shape of this one, it's narrow because A is greater than 1. Now the shape of this one, the absolute value of A is greater than 1, so it's narrow. Right? So that's a run through of this equation, the vertex form. Okay, we won't always be given the vertex form. A lot of times we'll be given the function that looks like the quadratic formula. Here's an example. I have a function f of x equals x squared plus 10x plus 23. Find the vertex, axis of symmetry. Is it a max or a min? Step at time. Nope, that's it. So to put this in the standard form, to put this into vertex form, to put into vertex form, use complete the square. Okay, remember complete the square, set it equal to 0. Is A, the leading coefficient, is A 1? Yes. Check. So now move the constant term to the other side. So let's subtract 23. Next step is we add b over 2 squared to both sides. On the left side, only do what's inside the parentheses. On the right-hand side, work it all the way out. So we have negative 23. 10 divided by 2 is 5 squared. So it's negative 23. 5 squared is 25. 25 minus 23 is 2. On the left side now, we can complete the square. Whatever's under the square, the first term equals 2. Now, move everything back to one side. We have x plus 5 squared minus 2. We took it from standard form to vertex form. So the vertex, this is x plus 5, so it's at negative 5, negative 2. What else we're supposed to find? Axis symmetry. Axis of symmetry is x equals negative 5. And is it a max or a min? Well, since A is equal to 1, it's what's in front. It's greater than 0, so it opens up. Since it's an up, we have a min. And the min of the function is at -2. All right, so this finds us our vertex, axis symmetry, and we know what the min is. It's the y value. That's because that's the lowest value we have. Okay, now how do we graph this function? Variable plus 10x plus 23. We changed it to x plus 5 squared minus 2. So knowing this, the vertex was at -5, -2. So the vertex is -5, 1, 2, 3, 4, 5, and go down 2. So there's the vertex. In other words, that's my new origin. A is 1, it's greater than 0, so it opens up. Now, to help us graph this thing, we have to know the x-intercepts. We know how to find remember, the solution equals the x-intercept. We can use the quadratic formula for this one. Or we use complete the square. Or we can also use this one. Use the vertex form. Actually, I'll do using both. Use the quadratic formula. So if I use the vertex form, to find the solution, I have to set it equal to 0. First thing I do is get rid of the +2. So I add 2 to both sides. X plus 5 squared. I have to get rid of the square, so I have to square root both sides. Remember, whenever you square root something that's squared, you got to put a plus or minus in front of the other side. So that cancels. So what we have left is plus or minus radical 2 equals x plus 5. Subtract 5 from both sides. So we have let's say x equals -5 plus or minus square root of 2. So we have two solutions here. -5 plus square root of 2. X equals -5 minus square root of 2. Let's look at the quadratic formula now. We label A, B, C. A is 1, B is 10, C is 23. Put it in the formula. So we have -10 plus or minus 10 squared 4 times 1 times 23 over 2 times 1. So we have -10 on top, plus or minus 10 times 10 is 100, minus 4 times 1 is 4. 4 times 23 is 92 over 2. So it's -10 plus or minus the square root. 100 minus 92 is 8. Number 8 is made up of 2 times 4. 4 is made up of 2 times 2. So square root of 8 is 2. We have a pair. So we have 2 square root of 2 over 2. On top, 10 and 2, they both have a 2 in common. So I could factor out a 2. And they cancel. And we have left -5 plus or minus square root of 2. All right. So they both give us the same answer. They should. It's just that you choose whatever method works better for you. All right, let's look at example 2. We're going to find the same things. We're going to find the vertex, the axisymmetry, and is it a maximum or minimum? Our function here, g of x equals x squared over 2 minus 4x plus 8. First step, set it equal to 0. Is a equal 1? No, because in this case, x squared over 2 is the same thing as 1/2 x squared. So a is 1/2. So we have to get rid of the 1/2. How? By multiplying everybody by the LCD. The 2, get rid of the fraction. So we have 0, 2 times x squared over 2. The 2's cancel. Minus 2 times 4 is 8. And 2 times 8 is 16. All right. So now we go ahead and fix this one. Remember, when we put this, put it in vector form, which is ax minus h. Okay. So a is 1. So move the 16 to the other side. So we have -16 equals x squared minus 8x. On this side, because this is where it's going to end up here anyway. So we have x squared minus 8x equals -6. I just flipped them around. we have to add b over 2 squared to both sides. So 8 over 2 squared. 8 divided by 2 is 4 squared. Remember, on the left-hand side, leave it alone. So we know this is negative 16 plus 4 squared, negative 16 plus 16 equals 0. Okay, so this equals 0. Interesting. So we have here our first term, our first sign, and our last term. So here we're finished. So we have our function is equal to x minus 4 squared. So our vertex is at 4, 0. The axis of symmetry is x equals 4. And since a equals 1, we have a min at 0. The y value. Let's look at a couple more examples. I didn't think I was going to become 0. Example 3. Our function equals negative 2x squared plus 10x minus 23 over 2. Okay. The vertex axis of symmetry, max or min. First step, set it equal to 0. A is negative 2, so we divide everybody by negative 2. So I'm going to put this at first. So we have negative 2 divided by negative 2. They cancel. So we have x squared. A positive divided by a negative is negative. 10 divided by 2 is 5. A negative divided by a negative is a positive. So we have 23 over 2 divided by 2. All that equals 0. Basically, we put negative 2 under everybody. Now, 23 over 2 divided by 2 is a fraction over a fraction. Leave the top fraction alone, flip the bottom, and we get 23 over 4. Right? Now we have a leading coefficient of 1. So move the constant term to the other side. Negative 23 over 4. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Now we have to add b over 2 squared to both sides. Leave that alone. I can't do any further. We have to fix this side. So we have negative 23 over 4. Distribute that. So 5 squared is 25. 2 squared is 4. We have 25 minus 23 is 2 over 4. Makes it 1/2. Okay. So here we have x minus 5 over 2. Yes. Ah, yeah, that becomes 23 over 4. 25 over 4 is 2, 4. Move everything over to one side. So this is our function in vertex form. Right? So our vertex is at positive 5/2, negative 1/2. Axis of symmetry is x equals 5/2. And since a equals -2. Okay, yes. I know a equals -2 because of here, but here's what I forgot to do. At the first step, I divided by -2 across the board. So replace the -2 you divided in step 1 back into the equation. In other words, what we have to do here is we have to multiply -2 to both of our terms. You can't distribute inside there. So we have negative times negative is a positive. 2's cancel, so it's 1. Yeah, that looked pretty weird. Yeah, so our vertex is 5 over 2, 1. The axis symmetry is the same. And our A equals -2, which is less than 1, so it opens down. So we have a max at 1, since that's our y value. Okay. So that's using the vertex form. We have to, once we have a vertex form, then we could find all this stuff. Then we could then set it equal to 0 and find the equation, find our x-intercepts. Now the standard form, which is ax squared plus bx plus c. Here, this formula tells us a couple things. It tells us what a is. It tells us our y-intercept. Remember, the y-intercept is always the constant value. So y equals c. But to find the vertex and the axis of symmetry, and then the direction, to find these, we have to use a formula. Actually, we've seen the formula for the vertex. If you remember, when we did the quadratic formula, right? Remember, we had the discriminant is b squared minus 4ac. When it equals to 0, we found out that we only had one solution because the graph of that one is there. So the graph of this one is the vertex. So if we set this equal to 0, our x value becomes that. That's the axis of symmetry, or the x value of the vertex. So the vertex, if I give it to you in standard form, is negative b over 2a. Once you find that one, plug it back in the equation. And that'll give you the y value. So it doesn't take much, but once we find the axis of symmetry, we plug that value into the function. That gives us our y value for the vertex. Let's look at the example. And then direction, again, it's all a. If a is positive, it opens up. If a is negative, it opens down. Example 4. Negative x squared plus 14x minus 47. Because now that we know this one tells us a little bit more to find the x-intercept and the y-intercept. So what can we tell from this one? First off, we know that a is -1. So it opens down, and we have a maximum. We know the y-intercept is y equals -47, or at 0, -47. So the range, if I give you this, the range, since we know it opens down, this is the y-intercept. So it's the highest point when it's not, let's find the vertex first. I'm sorry, this is just the y-intercept. We have to find the vertex first. So the vertex, negative b over 2a, and put that back in there. So what is negative b over 2a? A is negative 1, b is 14, c is negative 47. So it's negative b is 14, 2 times negative 1. So we get negative 14 over negative 2. Negatives cancel. 14 divided by 2 is 7. So our x value is 7. So our axis of symmetry is at x equals 7. So take this value, plug it back inside our function. So we have negative 7 squared plus 14 times 7 minus 47. So it's negative 49, positive, positive. 14 is 98 minus 47. We have 98. That's this one. Negative 49, negative 47 is 96. So it equals 2. So our vertex is at the point 7, 2. So if we look at this graph, at 7, 2, we have a vertex. We know A is negative, it opens down. So our range is from negative 2. So our range is from negative infinity to positive 2. Right? Let's do a couple of word problems. Application problems, they call them, using quadratic formulas. Applications. Example 5. Example 5 says this. Maximizing area. A landscaper has enough stone to enclose a rectangular koi pond next to an existing garden wall of the Englishman's house with 24 feet of stone wall. If the garden wall forms one side of the rectangle, what is the maximum area that the landscaper can enclose? What are the dimensions of the koi pond? All right, let's look at this. He has a wall, and he's going to use that as one part of his koi pond. He knows the total length here, but these two sides are going to be the same. This side's not. So we know that x plus y has to equal how many? 24 feet. So we have 2x plus y equals 24. Let's solve for y. We got 24 minus 2x. So there's a function that we have. So that's this side. Question said, what dimensions of the koi pond will yield the greatest area? So we're looking for the area. Area is base times width. Or in our example, x times y. We know what y is. Y is this. So it's 24 minus 2x. So our area formula is going to be 24x minus 2x squared. Or putting it, we always want to put the highest exponent first. The reason for that is we need to know whether it opens up or down. Since we're looking for the greatest, the maximum area, but that's asking what x gives the largest y value. So if we were to graph this value here would give the highest y value. So we'll just look at the value of x. All right, so let's go ahead and solve this. So where's the vertex? Remember, it's negative b over 2a, and then we plug it back in there. So negative b over 2a. B is what's in front of the x value. So it's negative 24 over 2 times negative 2. Negative 24 over negative 4. Negatives cancel. 24 divided by 4 is 6. So the x component is 6. If I plug that back into my original equation, x 24 minus 2x. So I have 6, 24 minus 2 times 6. 24 minus 12. 24 minus 12 is 12, is 72. So that's the y value. So our area function is in our function, a is negative 2. We got we have the vertex. The vertex is here. So it's x minus 6 squared plus 72. That's our area function. So the maximum area occurs when the pond is 6 feet wide by 12 feet long. Okay, now how do I get 12 feet? Because remember, we have the wall here. If this is 6 and this is 6, what's this length? It was the 24 minus 2x. 24 minus 2 times 6. 24 minus 12 is 12. That's this length. All right. So there's that. All right, everybody. Yeah, there's more examples, but it's done the same way. It's quadratic, so look for the vertex, and that'll maximize or minimize. If it opens up, it's minimize problem. If it opens down, it's a maximize problem. All right. Have a good day, everybody. Have a great weekend.